the last of the winter webinars in December. Hopefully all of you are joining us and you're out there looking to learn more about the Hour of Code. Maybe some of you are doing the Hour of Code week this week. And I'm joined this week with Douglas Kiang, and he is in Hawaii right now, and I am actually in Newport, Rhode Island. So we are spanning from coast to coast, and it's great to have him here, and I'll kick it over to Doug now.
Thank you, Kate. It's quite an honor for me to be able to present. It is a kind of a partially cloudy day here in Honolulu, kind of in the 80s though, but you know, I'm looking forward to chatting more about code. You know, today is actually the day where we're doing an hour of code really across the country, or well, I guess Friday, I guess they're doing it across the country. And so, you know, here it's exciting, I think, to see so much attention being given to code and finding ways to get more kids involved in working with code. And I've been actually really pleased to work with, actually my wife is a programming teacher over at St. Andrews Priory, which is a girls' school in downtown Honolulu, and the two of us have been working together on a new approach to teaching coding that really focuses first on design. And so I'm pleased to be able to talk with you a little bit today about that. So let me go ahead and share my screen. I'm going to talk a little bit, and then Kate, I'd love, you know, I know you've got a lot to share, and it would be awesome to hear some of the stuff that you've been doing. And then I'm hoping we'll have some time to kind of have some informal question and answer, and we can chat. So if you have questions, please feel free to post them up to the chat window. And you know, I'm hoping this will be kind of an informal, as they say in Hawaii, sort of a talk story. So we'll just share.
I just wanted to add that for anybody who doesn't know me, I am also with EdTech Teacher, and I'm actually the web coordinator. So I take care of the website that you're on right now, viewing us, and all of our social media. And my background is that I really started I really fell in love with coding as a young kid, and then I lost that opportunity when I switched schools, and I ended up becoming an architecture major and an artist and a graphic designer. And then I ended up falling into the tech world through just a love of helping people and helping implement technology into these classrooms, with teachers always needing some help. And then EdTech Teacher sort of came along, and it was a great way to merge these skills of mine. And I take care of the website that you guys are obviously now on, but also all of our other websites. And I use coding as just sort of a way to get those resources out to people. So I'm happy to jump in with Doug here and take any questions any of you might have.
Great. Thanks. And for my part, I actually teach computer science at the high school level here in Honolulu, and I also work with middle school students as well. On the weekends, we teach girls coding and try to find more ways to teach kids programming that don't have to do with the traditional way of approaching programming, which is through robotics and rockets and race cars. And we think there are many, many other ways to get kids coding. And hopefully I can give people some ideas here. Don't have all the answers. We have a lot of questions, but we're trying to come up with better ways to teach different kinds of people coding and try to attract a more diverse audience. So I want to start with this idea of code, because we hear about that a lot. You know, we hear about code, and to me, what does the word code really mean? When I look at the word code, to me it implies a puzzle. And that excites me because I love doing puzzles and I love solving puzzles. And to me, the whole process of programming really is one gigantic process of problem solving. In other words, coming up against problems, finding out ways to be resourceful and find answers to those problems, and then moving on and finding the next problem. And so, you know, I always love doing puzzles and puzzle books and things like that. And to me, learning to code is that. It's a series of puzzles. And the value that I see in teaching coding is that aside from teaching kids how to create web pages or create apps, what we're really doing is we're giving them a process of problem solving. And we're giving them really vital critical thinking skills so that in life, when they come up against various problems, they'll have different strategies to work through those problems. And so that's what I tell kids, that's what I tell parents, that's why we're learning code. I don't teach code because I necessarily want to create more computer science majors. I think it's about much more than that. I think to a certain extent, we want everybody to feel like they have strategies for solving problems in an ordered sort of way, and that they have a strategy for dealing with taking a larger problem and breaking it up into smaller bits and then solving those problems. And that's really at the heart of what we try to do when we teach code. So, and it's fun too. It's a fun process. I think about something like this. Like, this is what's called an ambigram. It's a visual puzzle. So the puzzles don't necessarily always have to be text-based. I love looking at this because what happens is if you switch this over, it reads the same thing. So these were visual puzzles developed by Scott Kim, and there's a whole series of them. And so I love to think about what's the process involved in creating artwork like this. This is like an artwork puzzle. How would you go about breaking that up into parts and making them appear in certain ways? What would be the process that you would go through to even identify how would I take either a given word and flip it over, or start experimenting with letters and then see what words they spell? And so getting kids to articulate that thinking, that's coding thinking. Even if you're not directly going on and programming the next app, this is what I mean by teaching problem solving. It's getting kids to wonder, what if? How could I do that? How could I make that? So that's, I think, that's where we start when we teach coding. So my goals when I teach coding are basically this. What I'm trying to do is to redefine the traditional approach to coding. And I want to involve kids in whatever they do to be building things that matter, doing things that are difficult and worthwhile. To me, that's at the heart of a good curriculum. Whether it's a history curriculum or a computer science curriculum or a mathematics curriculum, whatever it is, we want to be involving kids in building things that actually make a difference to people, not just to turn in and get a grade. And I think that's what drives people and motivates people to do things, particularly things that are difficult, like programming and coding. It's not easy. So for kids to persevere through that, they have to really believe in what they're doing. And I'll give you more examples of how I try to do that. And ideally, what I'm trying to do, again, I'm not trying to create more computer science majors, but what I am trying to do is create coding literacy for everybody. You know, not all of us need, we don't all need to be the next great American novelist, but I think we all do need to be able to read. And I think that's where we're trying to go. We're trying to get kids to the point where they can look at code that's been written by a professional and kind of understand what's going on, kind of decipher it. So part of that problem-solving ability is not necessarily generating your own code to solve a problem, but looking at existing code and reading through it and getting a sense for what it does. And I think, you know, one could make the argument that you actually have to be able to read before you can write. So I think a good place to start is by looking at pre-written code. So I'll give you some ideas about that as well. So, you know, when we talk about redefining the traditional approach, here's kind of how I look at it. We have been teaching coding backwards for years. No matter what kind of coding language you take, usually the first thing that you learn is how to print out hello world. Pretty much any computer programming language starts there. So for instance, in Java, you type in at the command line system.out.println hello world. And we kind of start there. And we progress from there, and then we start teaching kids how to write you know, using variables. And then we teach them the concept of iteration and loops so that we can print out hello world 25 times in a row to the console. It's usually a little while before we even get into graphics and start looking at anything visual, and by that time you've lost half the class. So to me, that's kind of like if you wanted to teach somebody how to build a motorcycle, that's like starting by saying, look at these two gears and how they fit together. I have absolutely no idea where on the motorcycle that even fits, or what relevance that, how is that possibly relevant to what I'm trying to build. If I wanted to get somebody to learn how to build a motorcycle, what I would do is I would take them for a ride on a motorcycle. I would have them feel the power of the motorcycle, feel the wind in their hair. I would show them how that motorcycle could take them places that they weren't able to go before. And I would want them to fall in love with the concept of the motorcycle. Then what I would do is I'd say, okay, let's take the motorcycle and let's break it into parts. You've got the transmission and the wheel. And the transmission helps the wheels spin better depending on where you're going. And then you've got the motor, and the motor does this thing. And then you've got the steering, and the steering allows you to turn the wheel and do whatever it does. So that people understand on a large scale, how do these big parts fit together? Then at that point, it might be appropriate to drill down and say, okay, well, let's take a look at the transmission. Let's look at the 3 or 4 big parts that make up the transmission. And then you kind of work down that way. That's the reverse of how most programming courses are taught. We usually start at the very bottom and we work our way back up again, and that's where we lose people. So I think the place to start when we teach about coding and programming is you start with what kids know and what they're in love with, which is apps. Pretty much every kid has used an app. They have an iPad or they have their phone or an Android or whatever. They've used somebody else's. The kids have an understanding sort of intuitively about what apps they like to use, what apps they don't like to use, what makes apps easy to use, what makes them hard to use, but they've never really articulated it. If you ask kids what makes apps easy to use, that's an interesting conversation to have, and that's the point that I start with kids, because everybody loves to talk about their favorite apps. And everybody loves using them. And then we start talking about what are the big overall guidelines behind what makes them easy to use. Maybe they're clear, it's understandable what you need to do, the icons look really nice. We talk about those things, and that is where you hook kids and get them more interested in going a little bit farther, with maybe even starting to create their own app. But that's ultimately where you start. Now, one of the things that kids don't often know is there are actually guidelines. Like Apple, for example, has done a really nice job of spelling out exactly what makes an app easy to use, and they have certain guidelines that they use for developers. So if you're designing an iOS app, for instance, they've made it really clear, and you won't find any coding language here. This is all just common sense English. I actually assign this to kids, and I have them read about color and typography. I have them read about design and fonts. And Apple's actually done a pretty good job of spelling this out. Like it's hard to tap on the screen anything that's smaller than 32 pixels by 32 pixels. So don't do it. Don't create icons that are so small that when you tap on it with your finger, you could tap on something else by mistake. Or surround those icons with white space so that it's pretty clear what you're tapping. So they've thought through things like that. And kids, whether they realize it or not, have used apps that have been designed by the interface guidelines, and those apps are really easy to use. And so I'll actually assign these and have them think about it, and that's a great epiphany for them that somebody's actually gone out and articulated some of the things that make apps easy to use. So that's a nice place to start. So my goal really is to try to redefine the process. So we start from the top down. We start with a design first approach. We design stuff and then we drill down. And in the process of designing things, what I'm really trying to do is create connections between kids and the real world so that they feel like what they're making makes a difference. That's much more important, I think, ultimately than the programming of it. Here's some examples of some stuff that we've built with our kids. We have a carnival here at our school. It lasts for a couple of days. It's a huge, huge carnival. There are about 30,000 people who attend over the course of 2 days and about 250 on-campus parking places. So that's kind of a problem. People will circle around for hours and not find a parking place. So what some of my kids did is they created an app. They used Xcode, and they made an interactive map so that when an on-campus parking place opens up, you can look on the device and you get a push notification and it tells you something, And it was amazing how hard the kid worked on this, and how it was actually a couple of kids, how fulfilling it was when people were downloading it. And so they were watching the user statistics, and they had 250 downloads on the first day, they had 1,500 downloads on the second day, and then on the third day it kind of dropped to like 1 download. I think it was some guy in Turkey, but that was it. And the kids are a little crestfallen, but then I said, when you're creating an app for a 2-day event, on the third day no one's going to download it. But the ultimate thing was when they created this app, it was so much more motivating for them knowing that they had a real audience and that people were going to be downloading it. And so the idea of publishing something, I think, is a very powerful motivator. We had another kid one time who did an app for a local restaurant. And his idea was basically to allow you to select items from a menu and build your order. And then when you submit it, it goes via text notification to the restaurant so that they can have your food waiting for you curbside. And I think he worked for the restaurant part-time. And he worked really hard on this. He solved all kinds of really difficult problems. And when he was done, he came out with this app that worked brilliantly. The problem was nobody used the app. And the reason is the restaurant specializes in shave ice. And shave ice is kind of like a snow cone. And it doesn't do really well with curbside pickup. because people would submit it, and then you'd be waiting 10 or 15 minutes out in the Hawaiian sun with a melting snow cone. And so this is a case where the student didn't really do enough research before embarking on this project. And it was a very difficult project. It was a good coding project, but in the end, he ended up producing something that was never going to be used. Now, in comparison, I had another group of students. These guys were a couple of athletes, and they had to come up with an idea for an app. And they said, well, we don't know what to do. So I said, well, where do you guys spend most of your time? And they said, well, a lot of the time we're injured, and we're in the rec room sort of rehabilitating from injuries. And so I said, okay, well, can we build an app around that? And they decided what they were going to do was they worked with a local physical therapist, and they came up with a list of the most popular rehabilitative exercises. And the problem normally is when you go to physical therapy, they'll give you like this Xerox sheet. And the Xerox sheet just has the exercises on them and no information really on how to do any of them. So they wanted to put in a video along with each of these exercises. And one of the neat things about it was they actually had to go and hire a model and arrange to have a video shoot. And this is all done prior to their actual coding. And these guys were awesome. They were so professional about dealing with this model and making sure she felt comfortable and she knew what to do. And they had to make sure they had the video the right resolution and edit all of it. And that was all before they were able to actually do the app, which they then coded and they put up in the App Store. And but I think the biggest learning for them wasn't even the coding; it was all of the organization around getting the project done that really impressed me. I had another student who worked with a parent of an autistic child, and she had developed a process to teach autistic kids how to count, but she had no way to share it. And so my student actually worked with her, and they created this app called Every Value Has Its Place, and they put it up in the App Store. And now this app is used all over the world by parents and teachers and therapists, people on all ends of the autism spectrum. And it's made a huge difference in teaching kids how to count. And the really neat thing about this was that this app would have never existed if it weren't for that connection between a parent who really didn't know anything about app design and my student who really didn't know anything about autism at the start, and now they each know a whole lot more. I had another student who did, for a project, he did an app for a local child psychologist, and it's an app for kids whose parents are getting a divorce. And he built in lots of different activities for kids to work through. Kids could tell their feelings and what they were going through in terms of artwork. They had like a painting program on the app. He designed things like flashcards so that kids could learn some of these unfamiliar terms that they'd be hearing through this divorce process. And what was really neat about this was that it started out just as a regular school project, and it ended up being something much more significant because it was a way for him to help other kids. It goes to the heart of what I'm trying to do, and that is build connections between the kids, the things that kids do in school, and other people in the community, so that their coding skills can help others and really make a difference. Because in the end, knowing that the work that you can do can help other people is the most enduring lesson of all. I think that's even more important than the coding skills. So helping kids to be good empathizers, to be good listeners, I think that's really going to serve them well, no matter what they end up doing. Maybe they're going to make a new app. Maybe they'll end up being social organizers or find other ways to do things. But it's really, for me, it's coding in the service of the community, which I think makes it very powerful. So I want to segue a little bit because we hear a lot of these terms used interchangeably. We talk about coding, we talk about programming, and we talk about app design. And in my mind, I've tried to separate those somewhat, and so I'm just going to show you my own definitions of these things. It's kind of what I use. I'm sure people might have different definitions, but this is kind of how I think about it. When I think about app design, for me, a design-first approach starts with this idea of app design. And it really can be taught at any age. And it's the concept of social empathy. What you're really teaching is you're teaching kids to listen to the needs, to listen to people, to talk to people, to brainstorm. Um, when you're designing, there are no wrong answers. You want to preserve ambiguity and allow ways for people to let those ideas bubble up. And some ideas that don't seem like you have a use for them initially, there will be uses later on. And so finding a way to record those things is really important. To me, app design also encompasses prototyping, lots of robust testing, a lot of iteration. And the reason that I say that this can be taught at the earliest ages is because you don't need to know how to code to do these things. But if you are going to code, you need to have design skills to get to coding something that matters. Otherwise, it's just a pointless exercise. I think you have to start with a sense of design. Otherwise, you're going to be building something that nobody's going to be using, like the Shave Ice app. So what are some things that you can do? We actually, at Punahou, we like to use the design thinking approach. And the design thinking approach basically is an iterative process. And it starts with this idea that design is inherently social. So when we talk about 21st century skills, we want people to collaborate, we want to teach kids to work with each other, we want to build listening skills. All of that is inherent in the design thinking approach. And again, it preserves ambiguity. There is nothing that's final. There's no final right design necessarily, because you're constantly iterating, you're redesigning, and you're testing. And you're going through a process of rapid prototyping, so you get something out there quickly. And the idea is, it doesn't matter if it's perfect in code. You know, you can do something on paper, get it out there, test it with people, talk to people, observe them, watch what they're doing, and then create something that works well for real people, not just for engineers or for coders. And so, you know, the whole idea with the design thinking approach is trying to get something from your idea, from your head, out onto paper or out into some usable prototype as rapidly as possible, so that you can then iterate through and redesign it quickly. So you're trying to make your ideas tangible. This is actually a big area right now that is redefining how we learn programming. There's a fantastic essay that's online by a guy named Brett Victor, and it's called Learnable Programming. And if you haven't read that yet, if you're interested in teaching programming, take a look at Brett Victor's essay, because what he talks about is a sea change in how we teach programming. He talks about the idea that there should never be a barrier between the code that you write and the results that you see. In other words, this whole process of writing, and then you compile it, you fix the bugs, before you can ever actually see what's going on, you kind of lose that inspiration. So you want to try to get the code to show up while you're writing it. And a lot of his ideas, I think, happen to be expressed in the newest version of Xcode that Apple has put out. They use a feature called Playgrounds. And the idea behind Playgrounds is you're writing a Swift code, but you're actually seeing the results of what you're writing very, very quickly. And so that's kind of a glimpse over the horizon right now. Swift is brand new. Playgrounds concept is brand new. But if you're thinking about finding ways to teach programming, I think Swift and Xcode are definitely worth looking at, because they make your thinking visible while you're doing that coding. But again, as I said earlier, you don't even need to be coding at the point where you're prototyping. I start out with an activity that's actually an offline activity. I call it the Does It Suck activity. And this is a great way to get kids thinking about design. If you can picture this, I usually have a group of kids in a room, and I'll have them stand in the center of the room, and I'll call out a series of things. And they have to decide, does it suck or does it not suck? And you have to stand on one side of the room or the other. So I'll say, okay, this is the suck side, this is the don't suck side. And so you have to go and you have to decide. So if I say exercise, you have to decide whether exercise sucks or it doesn't suck. And you go and you stand on either side of the room. And this gets kids up out of their seats, and they're moving around. And then you can ask them questions. Okay, why does exercise suck? Okay, why does it not suck? And then you'll call out other things like, you know, standardized testing. Sucks or doesn't suck? What are the pros of it? What are the cons of it? Some oversleeping. Kids will often say oversleeping sucks. Okay, well, maybe it doesn't suck. Maybe you really need your rest. But we talk about that, and then after we do that activity, I'll call out like 4 or 5 terms, and it'll take maybe 5 or 10 minutes. And then I'll have kids break up into small groups, and I'll say, okay, what I want you to do is now I want you to make a list of 5 to 10 things that suck. 5 to 10 things that you guys all agree suck, and just write them down. And so I'll get lists of things like, well, these things: exercise, standardized tests, oversleeping, confusing schedules, carpooling, all those kinds of things. And then what we'll ask is, and then we go around, we share it. They're pretty funny what some of the kids will name, and we'll come up with some. Maybe there are certain ones that lots of kids have come up with, so we'll make a note of certain things that a lot of people think suck, and then I'll say, okay, let's look through that list. And let's circle the ones that can be solved with an app, because not everything that sucks can be solved with an app. Getting old. That really sucks. I don't think an app is going to solve that. But, so not everything does. But some things can. Like, for instance, like the block schedule. All right, why does the block schedule suck? And how could we solve that with an app? And so, see, what we're doing really is we're starting with this idea of what are the needs. And a fun way to do it is to say, okay, what are the problems? And usually we use kid terminology. What sucks and why? And so what we've really done is taking them through a needs identification activity. And now we're starting to drill down and we're saying, okay, let's look for one or two specific things and start prototyping and coming up with sketches. And that's where we go to this other app. It's an online app. It's a web app. It's called AppGyver Prototyper. And this is free. And the URL I stuck in the very bottom there, appgyver.com/prototyper. And what this allows you to do is it allows you to upload images, and then you can hot link those images. And you can create, essentially what you're creating, some of you may remember a long time ago, there's this thing called HyperCard. And HyperCard had a stack of images that had hotspots that you could designate. And when you tap on the hotspot, you can go to a different card on the stack. That's essentially what AppGyver Prototyper does. The free version, I think, has 3 screens. But what you can get kids to do is start thinking about, in terms of app design terminology, what they're really designing are views. Every screen on an app is called a view. And they don't have to write the code to switch the views, at least not yet. What Prototyper does is it does it automatically. You can select certain hotspots, and you can designate them to go to a different view when you tap on it. And so what it allows kids to do is very rapidly prototype an app. It provides a QR code, and the QR code can be scanned, and then you can actually run it on your phone, and it looks like a regular app. And so here's an example here of an app that one of my students did. She decided she wanted to solve the problem of block scheduling, because the block scheduling in her class, in her school, is kind of crazy. Every class starts at a different time, like depending on the day of the week. Sometimes your class starts at 12:57, sometimes it starts at 1:03, and so the kids have a hard time keeping track of that. And so she wanted to come up with an app to design it. And the first step that she did before she started programming was she storyboarded it out by sketching out those views, and then using AppGyver Prototyper, she uploaded the sketch. And so this actually works like a handheld app. If you want to try this out, this is really cool. If you have an iPhone or an iPad, like right now, if you go to this URL, or if you search the App Store for AppGyver Scanner, it's a free app. And when you download it, you'll see a scan button. And if you scan that QR code that's up on our screen right now, it'll actually download her app. And you can actually tap on things. And it's funny because it looks exactly like an app. She did her homework. So, she has the little gear icon, and she's got the little screens, and she's designated certain areas of the screen as hotspots. So as you tap them, it'll actually switch over. And so, sometimes I get kids saying, oh, I want to make an app. And they don't understand that making apps is really hard. There's a lot of coding that's involved. And these kids might be in 6th grade, 7th grade. They're not going to be CS majors right away. Maybe they will be later. But when they say I want to make an app, what they're really talking about is I want to solve a problem. My mom is always getting lost. I want to create something that's going to help my mom get to where she wants to go. They're really looking to solve a problem. And to me, that's laudable. I want to support that. I don't want to bring these kids down by saying, hey, you know what, let's go into Xcode and do a Hello World activity, because that's where you're going to need to start if you're going to start coding. Programming is really difficult. But what if they could go through this process of identifying why is it that my mom gets lost? And how can I create screens that will help her find her way? And how can I draw and prototype these things in something that will run on her phone that basically looks exactly like an app, only I didn't have to code it? haven't we accomplished a lot already? Haven't we empowered that kid to feel like this is something that I can do to help others? To me, I think we've done a lot of really powerful things there. And then maybe later on, if that kid decides to really put in some time and study, it's like learning another language. Then maybe they're going to start creating apps. But I think this is where we start, and this is where we gain a lot of support and a lot of kids feeling empowered, like they can do this and they can make a difference. And it starts with this idea of prototyping. So again, definitely worth taking a look at. The other thing that I'll put in here, I don't have a slide for this, but there is a guy named Amir who created this product called Keynotopia. So it's like Keynot, OPIA. Okay, Keynotopia. He's created a bunch of templates for PowerPoint and Keynote. And what he's done is he's taken all of the graphic elements that go into making an interface, so everything that the human interface guidelines specify, he's made them in Keynote. And so what it means is you can now use Keynote as a prototyping tool. So I could assign to my kids, okay, here's this Keynote deck that's got all the interface elements in it, and you can double-click on them and retitle them if you want because it's in Keynote. And I want you to build the views for the app that you want to design. And then we upload them to AppGyver Prototyper, and we have it working like a functioning prototype of an app. And then we can test it out, and it's easy to change. If people decide they don't like the color, it's easy to change that. That is a great way to prototype, and not that expensive, and it doesn't involve a lot of coding. So that's definitely something that's worth taking a look at. This is actually paper prototyping. And this is something that can be done. Take a look at what they're doing here. They're actually, can I play this? Is this going to play for people? I don't know. I'm kind of hearing it's kind of loud. I'm going to skip the ad. Okay. So this is a session where they're actually viewing what's going on.
Doug, when I used to work for a school and we were prototyping a website and we wanted to know how that people would use our website, we would actually draw out the website and do the same thing that this video is showing, which is you click a button on a post-it note. And it was a way of still getting the information you need to solve a problem. And it's what we did in the real world. So you're not sort of, you never want to think that you're dumbing it down for students, but this really does mirror what happens in the real world, because all we want to know is how people got information on our website and what the best way to do it is. Because as a web designer, you may think the best way to create a website is. You don't actually know what the best way is until you test it with real people who would interact with your website. So this definitely reminded me of what we called usability testing when I worked for a bigger department.
Oh, thank you, Kate. Yeah, and that's very validating because you're a programmer. I'm not a programmer. I'm actually a teacher. But I've done enough programming to know just how much it takes to change like little things. Like if you decide, oh, you know what, this needs to be somewhat different. There is so much involved with doing that if you want to do it in code. So prototyping in code just doesn't make sense. You don't have the time. So changing it on paper is super easy. And I know I have to work so hard in code to get little things to happen. By the time it happens, I feel so good about myself that I've kind of fallen in love with it, and then I don't want to change it. And so even if people have a hard time using it, it's like, too bad. I worked really hard, so I'm going to keep it that way. It's an impulse I think a lot of developers feel, and so that's why I think it makes such good sense to start with something that is easy and quick, and it's not a precious prototype. It's something that can easily be changed.
That's a great way of putting it. Even today, I'm working on a new website for EdTech Teacher, and I've been so involved in it, and someone had like a small criticism, and I would be like, but no, that's how I made it. And I realized, I'm too involved, and learning this process can be such an important life skill. to be able to take criticism, to be able to know that what you think is going to solve this amazing problem might not necessarily be the way that solves it for everybody. How people use your app, and usability is something we can really teach our students. You mentioned talking about fonts. You know, how many times has someone gotten a presentation from a girl who thinks that pink on yellow is beautiful and they really want to show it to everybody? But in reality, if you have this conversation with students at a younger level of, you know, we can't always make what we think is always going to be great isn't necessarily what's best for the general population. So teaching just important skills like what, you know, just as PowerPoint, you know, you shouldn't use 12-point font. The same thing applies. And I think it's something that, as if you're coding by design and you're creating these things, it's something you can learn. It's a very important skill you can learn along the way of creating something that solves someone's problem.
Yeah, great. Thank you. I couldn't have said it better. Absolutely. All right, let me move on here. Going to talk about coding, and that was app design, right? Now the thing about coding, okay, I make a distinction between coding and programming, because you can actually teach coding at a very early age, because if you wanted to actually make an app now, you can make an app without necessarily knowing how to write a lot of code, because there's a lot of code that's pre-written that's already out there. And I think if you do the app design portion properly, you've already got kids understanding a little bit about the overall construction of a program. So just like we talked about how a motorcycle is made up of 3 or 4 major parts, if you break up apps into their interface and you talk about it, kids start to understand that apps consist of views, and then there's basically a model that actually does all the work, and then you have a controller that basically mediates between the different views and sends information to the model and gets information back again and redraws the views based on what they're getting. And so having a large understanding of the broad organization of an app, you've already started that process. And then with coding, essentially what I think when I think about coding is that connective tissue that kind of makes components kind of fit together and work together. And so particularly if you're working with HTML, CSS, what you're really doing is you're writing formatting code, and in many ways you're making links between components that you didn't necessarily write. Other people wrote them, or they're open source, or they're licensed code, and a lot of coding involves making something really cool by combining things that already exist but putting them together in unique ways. And that almost like building with Legos. You're not making the Lego parts, but you have to understand what each of the Lego parts does and how you can combine them to make something unique. And so to me, you know, I think anybody can learn how to code in that way. A lot of it has to do with finding resources online. There's a huge open source coding community. Scratch is a great way to start if you want to go beyond the hour of code. Scratch really is built from the ground up to emphasize this idea of borrowing and citing code from other people, putting them together and combining them in different ways, and then sharing on and commenting on what other people do. In the programming world, GitHub is where a lot of that happens. And GitHub is a place where programmers share their work. And I actually use GitHub to track all of the work that my computer science students do. I have kids working right now on independent assignments. So I took a screenshot of this just a little while ago. And you can see each of these kids is one of my students, and they're creating their repository. They just started their game projects, so they're programming a game. And the kids have created a repository, and the repository is where they're storing their work in the cloud. And the nice thing about it is I can track what my kids have been doing. So the kids have about a week to work on this project. And basically, this is the history of this student, from their final commit message to every time they do something where they're like, yes, it works, that's when you commit your code. So you send a snapshot of your code in its current state up to the cloud, and then you comment on it and you write, what did you do? Now, I used to have kids keep an independent work journal so that I knew what they were doing for their homework when they were working on their independent project. GitHub commit messages kind of took the place of that. So now kids are actually working on this, and if I want to go back and see exactly how much code they've written from commit to commit, I can see the work they did in the last day or the work they did in the last 2 days. I can see how many lines of code they've written, what they've changed, where they changed something. The kids themselves can back up. So if they get themselves, it's just not working, they can back themselves up last point where the code was working and then proceed from there. And so this is a neat way for me to work that my kids do in code. But honestly, I'll tell you, this would be a great thing for English papers, for just about anything, because the idea of using GitHub to store your stuff in the cloud in its incremental stages, I think, is a very powerful. The next place we're going to go with this ultimately is, as my kids develop code, I'm going to ask that they publish their work to GitHub in a way that's open source that other people can use it. So all of my kids are programming games for a little handheld device that's based on the Arduino, so they're working in C, essentially. And so some of the kids are coming up with code that's going to work a cursor, so you can move the cursor around the screen. So I'm going to say, well, what I want you to do is take that code and package it separately, call it moving cursor, and allow other kids, they all know each other's GitHub usernames, but allow other kids to use that or at least see how you did it, and then borrow some of that code if they wanted to in their own code. And so I hope to take away some of hurdles for kids, because starting from scratch, no pun intended, starting from nothing and creating a game is really hard for some kids because they just have no idea where to start. But at least if I can get kids coding, in other words, reading pretty well through the code and understanding what the code does, understanding where to modify it to get it to work in their project, and then citing and attributing their code where they got it to the kids who developed it. I think that's really important stuff that I'm trying to teach them, and it goes beyond the basics of just code themselves. So GitHub is free, completely free, and they even made this thing called the Student Developer Pack. And if you're interested in this, you really ought to get your kids to go to this website, education.github.com, and they have tons of resources here for people. And they're actually free subscription system stuff that really costs money. There's this one site that I use called ScreenFlow, which allows me to screen share with people. It normally costs $10 a month. They've made it free through education.github.com, but it's just for students. So I asked all my kids to go to this and sign up for it because it doesn't cost anything, and lots of cool free resources, and it gives each of them automatically a GitHub account that they can work. And again, when we talk about literacy, I'm talking about being able to read code that's written by other people and understand what it does. And the more kids use GitHub, the more they browse GitHub projects, and there's stuff in all different languages. The more they look at it, I think the more it increases their coding literacy. I'm starting to kind of throw out random resources, so hopefully we can throw this in the chat. But I just remembered this resource that I use all the time that I'd love to share with people. So it's called projecteuler.net. And can I actually go to, let me see if I can go to a...
How do you spell that? I can type it in the chat here.
Yeah, so it's project, Project,
yep.
Euler, EULER.net.
EULER.
Yeah.
EULER.net. Okay.
So what this does, the reason why it's powerful, is this allows you to solve different kinds of problems. Like they might say, find a way to summarize all of the prime numbers between 1 and 1,000,000. And so they're problems that demand a computational solution, but it's language agnostic. So in other words, they just want the answer. So some kids will code it in Python, some will code it in Java, some will program it in different languages, but it allows you to upload that code, and then once you get the right answer, you have access to a forum, and you can see how other people have solved that problem. And it's a great way to look comparatively at different languages to see, wow, that's interesting. The Python solution took about 4 lines of code, and my Java solution took 16. What's up with that? And so it gets kids comparing and looking at the difference between languages. And I think that's where we're really talking about programming. Not everybody's going to end up at programming, and not everybody has to. I think when you start with app design, you cast the widest net. You get kids who are authors, who are artists, who are actors and thespians, who are prop designers, kids who are going to be interested in in maybe starting to pick up some coding to create interactive props or interactive artwork. They're not going to be CS majors, and that's okay. But we increase that level of coding literacy for everybody. Some kids are going to want to go to programming, and that's what I think of as the most computer science-y area. And I think it's totally worthwhile. I would love to have the number of computer science majors increase in this country, but that's just a portion of it. But, you know, computer science is a pretty hot major right now, and it's one of the few majors for which there are jobs. When you walk out, you're going to have a chances are you're going to have a job if it's in computer science. But really, when I think of computer science, it's kind of like we want everybody to know how to read and write, but not everybody needs to major in comparative literature. And that's where the programming, the computer science field really kind of looks at. It looks at not just what's the quickest way to solve the solution, but what's the best way to solve it. What's the most elegant way to solve it? How can I create code that's reusable by others? You know, how can I document it in the clearest way? These are all really important skills. I don't think everybody needs to have these skills, but if you're going to really study computer science as an official discipline and as a language, I think that's where we look at programming. I don't think we need to teach programming to everybody, but I think everybody needs to have a basic level of coding literacy, and you'll get more people doing coding and programming if you start with app design. And so projecteuler.net, that appeals to the programmers. The kids not interested so much in solving the problem as they are what's the best way to solve the problem, and that's where I think that's an awesome site.
Yeah, Doug, it's interesting that you say about that's where the computer science majors are, because I was an architecture major. I didn't actually set out to go into computer programming. And very rarely do I actually code. You know, yesterday I was developing a website and I ended up, it wasn't doing exactly what I wanted to. I was just doing a Google site. But with Google Sites, you're able to go in and edit the code. And because I did know how to code, I was now able to make that website do what I wanted it to do. If anybody asks me what I do, I really say I'm a web designer and a problem solver first. I don't consider myself a coder. I would actually consider myself an artist beyond anything else. And I use coding like I would use a paintbrush or a graphic design program or any type of way to creatively express what I'm trying to do. Coding is not my job. Coding is just one of the tools I use to accomplish my job.
Absolutely. That's great. Yep. And not everybody is going to be a professional writer, but I think everybody needs to know how to write and feel comfortable with words. And I think we're getting to the point now where we're writing code and writing in a programming language, no matter what it happens to be, because I think the languages will change. But that skill set of being able to take a complex problem, break it down into stages, and then use whatever language you need to solve those problems, that's going to be central to so many different professions. I had a colleague of mine who is doing graduate work in astronomy at the University of Hawaii. And he said to me, yeah, on the first day on the job, they said, oh, you have to learn this language. And it was a different computer language. I'd never even heard of it before because it's only used by astronomers to scan large sections of sky for anomalies. And they slapped this huge manual on his desk, and they said, here, you have 2 weeks to learn it. And he was like, wow, all right. That's the kind of skill set. I think what we want for our kids is to be resilient, resourceful learners who aren't going to be taken aback with this idea that, okay, to do my regular job, whether it's an artist or an astronomer or, you know, whatever it is, I need to know how to teach myself how to learn this stuff and how to, you know, communicate. That's what we're trying to do. And to get at the big ideas of programming, code.org, of course, is a great resource. And, you know, every language is going to have ideas about iteration, do something this many times, conditional statements, you know, if this is true, do this, otherwise, you know, do something else. And the idea of methods, in other words, you can take code and you can reuse it by assigning it a name and passing in parameters so you can use the same code and have it act on different inputs. All of those things are pretty much central to any language, and if we give kids from the earliest ages an understanding of those big core concepts, then the learning that we're doing is language agnostic. We're teaching about thinking about coding, and we're teaching a process of thinking. In many ways, coding is the language of critical thinking, no matter what programming language you're using.
Barbara just said in the chat that coding is art, and I'm actually working on sort of a blog post of how to put together of arguing that coding actually should be put underneath your arts department, because really it is just another expression of learning, and coding can be Doug, if you just want to go to the next slide if you can on yours.
Sure.
Because Mitch Resnick, who created Scratch at MIT, has this phrase, learn to code, code to learn. And it's the whole idea that, if you're learning coding, coding can just be another way of expressing your ideas. And if you go to the next slide, I have just sort of, you can fill in the blank, learn to code, code to learn math, code to learn science, code to learn art, code to learn English. It can really just be the same way as you are expressing your ideas in English through a paper, or science in a lab report, or art on a painting. Coding can just be another medium for that expression of your learning. I don't create a website just to create a website. I create a website to offer resources for teachers teaching technology. The coding just becomes secondary to being able to express those ideas in the easiest way possible and solve problems, which is really at the heart of everything we've been talking about tonight.
Yeah, and absolutely. Oh, yep, there we go.
Yeah.
So, actually, do you mind if I just skip back here for a second? Because I do want to briefly touch on tools. People are often curious about tools. Everybody always comes up to me every week. Somebody comes up and says, I want to make an app. I want to make an app that does whatever. And one time I had a kid, he came up to me and said, I want to make an app for my squash club. And I said, well, what will the app do? And he said, oh, okay, well, we want to know when the squash courts are reserved, and I want anybody to be able to access it so that they can sign up for the squash court and they can see if it's reserved for that time. And I said, oh, okay. And it turns out he wanted more. He wanted everybody in the club to be able to use it. So I said, okay, well, what you really want is not an iPhone app necessarily. What you probably want is a web app, because it's going to have to interface with the database that's stored on the web anyway. And the interface is fairly simple, and it doesn't, you're not accessing the GPS or anything else. Just do it as a web app. And so he said, oh, okay, how do I do that? Okay, well, then that's web technologies. That's HTML5, it's CSS3. Here's the manual. Take a look at it. Here's some people you can talk to. I had another kid who said, I want to create an app that keeps track of my change in speed and elevation when I'm on the ski slope, when I'm skiing. Okay, you can't do a web app for that, because I think maybe the later web apps can, but generally you can't access the hardware of your device to tell how fast, what's the change in distance using the GPS, and what's the change in elevation. You can't, the best way to do that is to use something that's hardware specific. So for that, he created an iPhone app to do that. I had another kid who wanted to create a story that was like a choose your own adventure story. Well, there's already a really great programming language that exists called Inform, and that's free. And we use that to teach interactive fiction. You already have, what she really wanted to do was tell the story. She was less interested in actually doing the programming part of it. She wanted to really tell a story using beautiful. Form 7 allows you to do that, and at the same time it introduces you to some basics of programming using very simple English-like coding language. And so that's a great place for people to start. So again, people often want to start with the end and create an iPhone app. What we're really trying to do with the design first approach is we want to start with what's the problem, what are you trying to solve, who's your audience, and then from there, lots of different options for coding and programming. And a lot of it really just depends on, what the need is. And no one of us can be experts in all of them. So I think our role as teachers really is to help kids become resilient, resourceful learners, know what the strategies are when they get stuck, and be able to point them in the right directions. I've got kids now who did an iOS app last year, and I regularly match them up with kids this year who say, I want to do an iOS app, what's involved? I'll say, gee, you should go talk to Shauna because she just went through this last year. She can tell you better than I can. And so really what I am, I'm a connector. I'm trying to connect kids who know stuff with kids who want to learn stuff. And I think that's ultimately where, as educators, we can be really effective in helping kids, empower kids to kind of take learning into their own hands.
And that's an important skill to teach to be lifelong learners because, when I graduated college, there was no iPhone or iPad, and that's only come about in the last 7 years since I've graduated. And so I've had to teach myself how to create a website that can work on a phone and on an iPad and on an Android device and on a Chromebook. And that wasn't available to me. It's being able to create and be able to be comfortable with not knowing the answer and where to find the answer. And that's, I think, an important skill that is whether you are learning coding or whether you are working in any field, is being comfortable to not know the answer, what I like to call mistake tolerance, and being comfortable to try something and, oh, maybe it won't work or maybe it will work. But coding lends itself in the education world to giving those skills to students.
Do you want me to go forward?
Yeah, I mean, right now we
Okay.
just have a bunch of resources in the slides, but I posted in the forum chat here if anybody has any questions, and there's no questions as of right now. This slide is just about Thomas Suarez, which I just like to share him. He's inspirational. You can see that he's had over 2.5 million views on his TED Talk, and watching him is pretty great for students who might want to, see that there is a student just like them. He's not a prodigy. He created an app because he didn't like Justin Bieber and he wanted to be able to hit Justin Bieber's face. So he created an app called Bustin' Jeeber. And now he's giving a TED Talk about his experience. So that's sort of why I shared that. So I encourage that you guys check that out. And I see that people in the chat are sharing their contact info. Barbara, I will definitely be in touch with you about your art curriculum and coding because that sounds fascinating. And I think the rest of our slides are just more resources, and this whole page and this webinar recording will remain on this page for the rest of, I mean, we have no intention of taking it down. So feel free to share it with your colleagues, tweet it out, and we're here in the chat for the next couple minutes. It doesn't look like anybody have anything right now. Doug, do you have anything else you want to say before we wrap up?
No, that I'm just thrilled to. Getting stuff that matters.
Are you there? I think my connection just started froze. Okay. So in that case, thank you everyone for joining us. Doug is actually, I'm going to shamelessly plug him. He is our keynote speaker in San Diego for our iPad Summit. This is the second time we'll be doing this on the West Coast, and it's our 5th summit overall. So if you're interested, please check out ettipad.org to register. Early bird registration is open. And then looking even further down the road, whether Doug knows it or not, we are going to be doing a summer workshop together at some point this summer. So come and join us for 2 days of hands-on learning with coding.
Absolutely. Would love to see you there.
Okay, bye everyone.
Bye-bye. Thanks.